on properties of parallelograms. The types of parallelograms we're going to discuss are square, rectangle, rhombus, and parallelogram. We have properties of all four types of parallelograms. In any parallelogram, any one of these types, the opposite sides are parallel. We use a little arrow like this to indicate that this side is parallel to this side. If you have the two arrows, it's going to connect to the side that also has the two arrows. Property 2, opposite sides are congruent. So you're looking for tick marks to indicate that opposite sides are congruent. Two tick marks go together, one goes together with that one. Property 3, opposite angles are congruent. In a square and a rectangle, all the angles are 90 degrees or right angles. But in a rhombus or parallelogram, the ones across from each other are opposite and those angles are equal. Property 4, consecutive angles are supplementary, meaning they add to 180. So when we go around a shape, consecutive angles are angles that are next to one another. So angle 1 and 2 are next to each other. Therefore, if we add them, it would equal 180. 2 and 3 are next to each other. Angle 2 plus angle 3 equals 180. Angle 3 and 4 are next to each other. They add to equal 180, and the same thing with angle 4 and angle 1. So as we go around a shape, consecutive angles are next to each other, and they add to 180. Square and a rectangle, they're all 90. It's pretty self-explanatory with those two shapes. Property 5, diagonals bisect each other. That means if we have a diagonal, let's say it's 20, and we have another diagonal, that means right here is the middle. So this side would be 10. So from the corner to the middle is 10. From the middle to that corner would also be 10. If we think the other way, from this corner to this corner, we say it's 12. From the middle to this corner would also be 12. In a parallelogram, we do not know that these diagonals are the same. We just know that they cut each other in half. Okay, if we need to find the missing measurements of the following parallelogram, if I start with, I know side AB is 12, opposite sides are congruent, therefore CD would have to be 12. We can apply that same property for AD, it would have to be 23. When I look to angle A, I think, oh, my angle measurements. Opposite angles are congruent, consecutive are supplementary. Let's start with the opposite. Opposite angle A would be angle C, so angle C has to be 77 degrees. Now angle B is an angle that's right next to angle A, therefore it's supplementary. So if we did 77 plus angle B would equal 180. To figure out that missing measurement, we can just do 180 minus 77, which would tell us that angle B is 103. Now the angle opposite angle B is angle D. Therefore, angle D would equal 103 degrees. Now we're dealing with diagonals. So when I see diagonals, I know it's property 5. If AC equals 30, find AE and CE. Well, if we cut 30 in half, AE is 15, CE would also be 15. Now if we told you that BE equals 12, that means DE would also have to be 12. And the entire segment, if we take this 12 plus this 12, that tells us that the entire segment from B to D is 24. Now we can use these properties to solve for the value of x. So whenever we have to solve for x, we need to come up with an equation. So here I'm dealing with side lengths of a parallelogram. Well, I know opposite sides are congruent, which means I can set BC equal to AD. So 5x plus 19 equals 7x plus 1. And now I have to solve this equation with x's on both sides. I can start by, let's say I move the x's to the right side, because I don't want to deal with a negative. So that means I have 19 left over. Those cross off. 2x plus 1. Now I can subtract 1 on both sides. I'm left with 2x equals 18. Remember, it's an equal sign. Doesn't matter which direction we start with. To get x by itself, I'd have to divide by 2 on both sides. So x would equal 9. To figure out what the length of BC would be, we can take our x value and plug it in. 5 times 9 plus 19, BC equals 64. We know that AD should be 64, but let's verify that we have the right value for x. So if we plug 9 in for x, we can verify that AD is 64. Opposite angles are congruent. So we can say angle A is equal to angle C. Set up our equation. It's the exact same one. We're able to plug it in and say angle A is 64 degrees and angle C is 64 degrees. So if we have to use property 3, it's the same process. To figure out angle B and angle D, well, those angles are consecutive, meaning if I took 180 minus 64, that would leave me with these angles would have to be 116 each. I have angle A and angle B. Those are consecutive angles. So in order to solve for x, I would add angle A plus angle B, set it equal to 180, and solve. We need to combine our like terms. So we combine our x's, combine our constants. We get 16x plus 4 equals 180. Subtract 4 on both sides. 16x equals 176. Divide by 16 on both sides. X equals 11. Let's plug it back in. So angle A is going to be 6 times 11 plus 5. 71 degrees. Angle B, 10 times 11 minus 1, 109 degrees. We can verify 71 plus 109, that's our 180. So therefore, angle C, that's got to be 71 because it's opposite angle A. And angle D is going to be 109, opposite angle B. Our last property, diagonals bisect each other. Get cut into 2 equal segments. Therefore, we know that BE equals DE, so we can say 2y minus 1 equals 3y minus 8. Now again, I can move the 3y over here, but I'm dealing with a negative, so I'm going to move the 2y to the right side, leaving me with the negative 1, 1y minus 8. So to move the 8, I'm going to add it to both sides. So we get y equals 7. Plug it back in to find BE. BE equals 13. Plug it back into DE. We can confirm that DE also equals 13. So the whole thing equals 26. Now we have AE equals CE. We can set 3x plus 3 equal to 4x minus 2. Subtract our 3x, get x by itself. Add the 2 to both sides. We get x equals 5. And plug it back in for each segment. Each segment is 18, and the whole thing equals 36.